When groundwater becomes contaminated with PFAS, these so-called forever chemicals can persist for centuries. So ideally, we want to remove these tiny molecules and keep the clean water. But separating PFAS from water is really challenging. Separation is a process that can be found everywhere, from the production of food to the removal of PFAS from groundwater and even the purification of medicines to make them safe for consumption. For a simple example, think of desalination, where you remove the salt from seawater to make drinking water. We're doing something similar, but instead of just water and salt, we're separating all kinds of molecules from various liquids. That's true. Traditionally, you could simply boil off one of the substances to separate them, like when you boil seawater to remove the salt and capture drinkable water. This works, but if you do it on an industrial scale, it requires a lot of energy. Now, what if I told you that we don't have to boil our liquid at all? Because an energy-efficient and environmentally friendly alternative already exists, namely membranes. They act like extremely fine filters, only needing a pressure to push the mix through, so no boiling is required. What happens inside these membranes during separation is very complex, and it occurs at a scale of nanometers, which is far too small to see directly. This makes it very difficult to predict how well the separation will occur. So choosing or designing the right membrane for a given separation takes a lot of time and experimentation, making the traditional methods, like boiling, often a more appealing choice. We're developing machine learning models to predict how membranes will perform before running experiments. By modeling membranes in this way, we can speed up their implementation and use these models to guide the development of better membranes. This way, we can help industries adopt membranes that provide a cleaner, more energy-efficient method for separations, like, for example, the removal of PFAS from groundwater.